Yes, I was talking about the indexes.
Yes.
Yes, I am just continuing. So indexes will speed up the performance of the query in fetching the data.
Okay.
So here you can see indexes are helpful if the operations return only small portion of data, that is less than 15% of the data is being retrieved from the tables. Only then indexes would be helpful. Then the guidelines for creating the indexes. Do not create indexes on small tables where the number of rows are less, because it will not give any performance. And do not create indexes on those columns which contain many null values. Okay?
Okay.
Because it degrades the performance there.
Alright.
Then do not create B-tree index. Look here, there are various types of indexes like unique index, B-tree index, bitmap index. These are the names of indexes.
Okay.
Among them, do not create a B-tree indexes on those columns which contain many duplicate values. Suppose one particular column like salary may be having duplicate values.
Yes.
So do not create B-tree indexes on those salary kind of columns.
Alright.
Instead of B-tree indexes, you create bitmap index for those.
Okay.
This is another name of index. And limit the number of indexes on tables. I already told you.
Yeah.
Although they speed up the queries, at the same time, DML operations becomes very slow on all the tables which have indexes. Because all the indexes have to be updated whenever an update, delete or insert takes place on the tables. So you have to wisely create indexes on those tables which has a select query very frequently being executed on it.
Okay.
So creating the index. So you can see here create index followed by the index name. On what? So and so table, on so and so particular column. Okay?
Okay. Yes.
So if two columns are oftenly used together in where condition, then create a composite index on these columns. I mean, from a table, assume there are 2 or 3 columns which are very regularly used in select query.
Okay.
You can put those columns comma separated here. Okay?
Okay. Alright.
So you can not only create an index on single column, you can create index on multiple columns combination also.
Alright.
Then bitmap index. So create a bitmap index on those columns which contain many duplicate values and when tables are large.
Alright.
For example, city column or location column in employee table is a good candidate in creating bitmap index because location may be repeated for all the employees.
That's right.
Right. So how do you create that bitmap index? Create bitmap index followed by the index name.
On table.
On what table? On particular name, column name, city.
Alright.
Okay.
Yes.
So likewise, you can create function-based indexes also. Function-based index in the sense where a expression is involved in creating the index. Like in our examples, a city was involved in creating index. Employee number and department number involved in creating index, right?
Right.
Here employee number alone involved in creating index.
Yes.
Likewise, a function would be involved. So function like computing the net salary for an employee, salary plus commission. we can use an employee table salary plus commission together, an expression.
All right.
Then you can drop the index using drop index followed by column, that is index name.
Okay.
And all these indexes are stored in user indexes. Okay.
Yes, yes.
So that's about the basic knowledge on indexes.
Okay.
You may expect questions from these indexes in your interview.
Okay.
The guidelines for creating index are very important.
Yeah, yeah.
Next topic is clusters.
Okay.
So clusters are also database objects. They are nothing but some memory area, some portion in Oracle environment.
Okay.
So what this memory portion indicates and how we are going to create that particular memory portion. Look here. Assume there are two tables or more than two tables
Okay.
that are joined. So we can join multiple tables using joins. We will be seeing joins once we finish these clusters. Okay.
Yes.
So two or more tables are joined together on a single column. Generally, two or multiple tables are joined using single column.
Okay.
For example, in our employee table and department tables, if you remember, department number was common in both the tables.
Yes, that's right.
So you are going to join the employee and department table using department number. Let me show you here once. I am logging in. Yes, employee table. Look there, employee table. Yes, we have department number,
That's right.
and in department table we have department number, name, location.
So we
So
can
department
join.
number. Yes.
So we can join these two tables by department number.
Yeah, for sure. Yes.
Okay.
So most of the time you will be issuing the join statement on these two tables. It means you are going to use these multiple tables, two tables or more than two tables very frequently in your SQL queries. Okay.
Okay.
During that time you can create a cluster for these two tables because you are very frequently using those two tables. As you are using very frequently, then you a very good performance you will be expecting. So you better create these two tables in clusters. So how you are telling Oracle Engine to create those two tables in clusters is, so here you can see a cluster is a group of tables that share the same data blocks. All the tables are physically stored together. That is, you can see when you fire a join operation, look here, select star from EMP, comma DEPT, where employees department number equals to department's department number. I have written a simple select query.
Okay.
And I have joined both the tables. You can see here, right?
Yeah.
This is a join operation
Yes.
because I am using multiple tables here.
Yeah.
And I am joining using department number common column.
Yeah. Okay.
So this particular query will fetch some data, right?
Yes.
Along with this query, you can put a where class having all those things, of course.
Okay.
So when you put all those where class having all those things, then you would get some portion of data from both the employee and department tables.
Okay.
That portion of data is known as data block. Yes, done. Yes, here you can see.
Yes.
A cluster is a group of tables that would share the same data blocks. That is, you are going to use the same join query on these two tables very frequently. It means the same data blocks are being used, right?
Right.
Yes. So here you can see the employee and department tables are joined on department number column. Yeah, I have shown you.
Yes.
If you cluster them, Oracle physically stores all those rows for each department from both the employee and department tables in the same data block.
Yes.
If you are clustering them.
Yeah.
All those data that has been being fetched using a join operation on employee and department table would be stored in the same data block in the same memory area.
Okay. All right.
Since clusters stores related rows of different data in the same data block, disk IO is reduced and access the improves from joins of these cluster tables. I mean to say, again, I am referring to that, what is that? Yes, this one. Yesterday I have shown you one
Picture.
image, yes. Open. Yes, here you can see. Instead of the buffer here, you can assume this as a cluster memory area where you are using the repeated select query which has the data blocks, and that data blocks are stored here in this cluster.
Okay.
Now, whenever you are firing a select statement here from your browser, from your editor, then the Oracle engine is going to fetch data from here instead of fetching data from employee and department tables present in the database.
All right.
That is why the performance would be higher.
Yeah.
If you don't have cluster, always the database engine has to refer to employee table, department table, and join the data, then get the data.
Okay.
Instead, once it joins, it puts the data in a cluster.
Okay.
And whenever you are executing that, this data present in that cluster area would be fetched. Okay?
Okay.
That is why it is higher in performance. Yes. So each cluster key value is stored only once each in the cluster, and the cluster index, no matter how many rows different tables contain the value. Let me explain you here. Look here, we are going to create a cluster. Look there, create cluster followed by cluster name.
Okay.
On which column you are going to create? Common column, department number. Okay. So you are going to create the cluster first, then you are going to create the tables. While creating the tables, you will be referring to that memory block.
Okay.
So that whenever you write a select query, data would be fetched from that repeated data blocks.
Okay.
Yes, look here, first we are going to create a cluster with mentioning common column. Alright?
Alright.
Then you are going to create an index on it. So cluster has been created. Now you are going to create an index on what? On cluster you are going to create index.
Okay.
There is a possibility of creating the cluster on, creating index on clusters also.
Alright.
and you are going to name that index, cluster index we call it as,
Yeah. Yeah.
to speed up the performance. Then you are going to create the clusters. Here you can see create table, department table. We have already created a cluster, and now we are going to create an actual table, department and employee table. So during this creation we are referring to that cluster. Look here, department number, name, location, and you are going to say let the department table get created in the cluster, so and so cluster, which we already created.
Oh, okay.
Likewise, create employee table, employee number, name, salary, department, where in so and so cluster.
Yeah. Yeah. All right.
Then you can drop the cluster using drop cluster followed by cluster. Okay.
Yes. Yes.
Then so this will drop the cluster. If the cluster is empty, it means the cluster is dropped. That is, no tables are existing in it.
Yeah.
Then if tables are there in the cluster, first drop the tables, that's what. While dropping the cluster, you need to drop the tables first, then drop the cluster.
Okay. All right.
So if you want to drop the cluster, even when the tables are there, that is also possible by using query drop cluster followed by the cluster name including tables. Directly you can drop the customer including the tables. Okay.
Okay.
So listing information about clusters. So cluster data is stored in user clusters table. Okay.
Okay.
So here you can see, to see what the tables are part of the clusters, you can view. Yes. Look here, I am going to view the select query. Select star from tab. Tab is the table which contains all the information about the existing tables in Oracle environment.
Okay.
And here you can see cluster ID.
Yeah.
For now it is blank.
Yes.
Let me filter this to 500 and execute this. So for now it is blank because no clusters are created.
Okay.
Once you execute the above queries creating the clusters, then you can see for your employee table and department table there will be some cluster ID, some number,
Yeah.
which says that these two tables are present in the same cluster.
Okay. Okay.
Okay.
Okay.
Yes, that's about clusters. So you can expect interview questions on clusters. General information, what is a cluster? How do you create a cluster? What is the purpose of the cluster?
Yeah. And I have
Same
everything
way.
in this document.
Yes, yes. You can just make a try creating those clusters and dropping those clusters.
All right.
And generally, we application programmers will not be creating these clusters or indexes. Database administrators would be doing that job.
All right. Okay.
But still we have discussed it because we programmers should have knowledge on those things.
Yeah. Okay.
All right. I think you have received these documents. Did you check your mail?
Yes. Yes. I have. Yes. But I
Okay.
didn't answer. But I have
No problem.
downloaded. Yes.
Okay. You can take some time and download later.
I already did.
All right. Then we are going to run into next topic, joins, a very important topic.
The join tables, right?
Yes, join tables.
Okay.
Yes, please hold on. Let me have some water.
Okay, okay.
Hello.
Hello.
Yeah. So here, hmm, yes, there is a diagram. Okay. Huh. Let me introduce those joins, what the joins are and why do these joins are used in brief.
Alright.
So the joins is a topic under SQL where we are going to join more than one table in fetching the data. So there are some situations in our application programming where you are going to pull the data from multiple tables. We cannot always rely on a single table. So applications would be having multiple tables in it. So you need to pull the data from multiple tables. During that time, those multiple tables can be joined using these joins. So these joins are of various types. They are. So I am going to point out here. So joins. So joins are of various types like equijoin, left join, right join, self join, then Cartesian join. So these are the various types of joins which we will be regularly using.
Okay.
Equijoin can also be known as normal join or plain join. Plain join or natural join. Mostly you will be using this join, equijoin. So these are the alternate names for equijoin. You need to remember these alternate names.
I will.
Because if you don't remember, then you will think that these are again various types of joins. No. Equijoin is also called as these other, alternate names.
Alright.
Likewise, left join. So left join is also known as left outer join. Likewise, right join is also known as right outer join.
Okay.
Both means the same. Just they are the alternate names, that's it.
Okay.
Okay.
Yes, yes.
Now, let us look into this equijoin, what this equijoin is. So equijoin, here I told you that you can join multiple tables. Alright. So multiple tables are joined based upon what? Is there any common thing that is generally used in joining these two tables? Yes, there is a common thing. That is, there may be a common column between those two tables which would help us in joining those two tables. Example, the employee and department tables have department number as common, right?
Right.
Yes, you can see. I have already created a select statement here. So let me write here joins, and let me copy the stuff here so that it would be easy to you to refer to. That is block level comment, right?
Right. Multiply comments.
Yes. So here you can see how I have created a join using select operation from, look there, multiple tables are being placed in from class, comma separated.
Yeah.
And additionally, if you want, you can use a where class, right?
Right. Yes.
And when you execute this query, it is giving you around 14 rows.
That's true. Yeah.
Now observe here, I am going to remove this where class. I am just executing select star from employee comma department table without any conditions,
Okay.
without any where class. That is, I am just joining two tables.
All right.
And I am going to execute this. Observe carefully what it gives the result. It is around giving 56 rows.
Yes.
Yes, the thing is, again, let us back to our school age mathematics, basic mathematics. If you assume there are two sets, A equals to 1 comma 2 and B equals to, sorry, control Z, 1 comma 2, B equals to 3 comma 4. Right. How do you represent a Cartesian join on these two tables, A cross B? Do you remember your basic mathematics?
It will show all, I guess. 1, 2, 3, 4, 5.
Right. That's what. I'm going to pair up.
Yeah.
That is, the first element I take from A and the first element from set B.
Yes. 1,
Right,
4,
right.
1, 5, 2, 3,
Right,
4,
right,
5.
right.
5.
Comma 5. Right.
Right.
Likewise, I just use this and mention it,
2.
and here it would be 2, 3, right?
Yeah. 2, 4, 2, 5.
2, 4, 2, 5. Well, so how many elements you got here? That is, assume it is having m elements and it is having n elements. So how many elements do you have here?
6.
That is what m into n, right?
Right.
The same way here, you can see first element from set A is paired with the first element from set B.
Yes.
You can assume these employee table and department tables as two sets.
Okay.
From employee table, the first row is taken and paired with the first row in your department table. That is what the result you are obtaining here by executing this select star from EMP comma department.
Okay, now I understand.
Yes, you can see here from employee table first row
Yeah.
is still here, and it is being paired with the first row from department table.
That's true.
7839 is right, employee number. Somewhere again you can see 7839, which would be paired with second row. You can see here, right?
Right, right. Yes, yes, I see.
So like this, totally you get how many rows? There are 14 rows in our employee table and 4 rows in department table.
So 50. Four rows in department table and 14, right? 56.
In employee table.
Yeah.
Yes, absolutely. You can see the result, right?
Right, right.
Yes. So here the thing is, you are using a join operation by placing multiple tables in from class, and those multiple tables are separated using comma.
Yes.
And here, where you are not using any where clause with this particular join, then this particular join becomes Cartesian join. So I mentioned here Cartesian join, right?
Yes.
Suppose when the same select operation, so I am going to write here Cartesian join for your reference. Cartesian join. Now the same select statement, I am just copy pasting here, equijoin it is. I am removing this comment where clause, and I am removing this semicolon, and I am executing this together. Observe carefully, it gives the data, control enter. Yes, it gives the data, 14 rows, and what data it is giving is, it is giving the data of employees who are with some department number.
Uh-huh. All right.
Okay?
Yes.
So that's what it giving the data.
All right.
Yes. Again, let us back to that SQL joins, some narration about that. Here you can see I have mentioned two types of joins. I mean to say, joins can be represented in two styles. Previously I told you the various types of joins, that is inner join, left join, right join, so outer join, that is what left join, that is left outer join or right outer join we say. So here you can see there are various other things also. You can just refer to this document once you are good at joins. For now you can exclude these things, remove these things. I am focusing on those things which I highlighted here in our joins.
Okay,
Joins also using these things. Okay?
Yes, yes.
Yes. So joins are represented, I mean to say, in what way you are going to represent joins? The style of representation. There are two styles, theta style and ANSI style. ANSI style is preferred style. The IT industry is using ANSI style in representing the joins. Theta style is also known as old style. ANSI style is known as modern style.
All right. Okay.
Fine.
Fine, fine.
So in theta style, which is also known as non-ANSI standard, join operation is performed in where clause in the query. If you observe our SQL query, in our SQL query, we are joining the employee and department tables using the common column department number. How I am referring it? Employee dot department number equals to department dot department number, right?
Right, right.
I am going to use that particular join operation, join condition in my where class.
Okay.
So this is the theta style representation of a join operation I have used.
Okay.
So in theta style, you are going to represent the join mentioning the tables comma separated in from class, and you are going to put the join condition in where class. That is how you can identify a theta style join, and that is how you can represent a theta style join.
Okay.
One, that is representing multiple tables comma separated in from class. Two, and representing the join condition in where class. You can add further and or conditions and put other where conditions also, of course, based upon your requirement.
All right. Okay.
Good. Yes. So in the from class, the tables are listed as if with the Cartesian product. With the Cartesian join also, I told you the same thing, right? Comma separated tables without any where condition.
Yes. Yes.
That's what I represented. And the where class specifies how these joins should take place. So in where class, I am going to put that condition how to join these two tables by using the department number column. Okay.
Okay.
And this is the syntax to represent the join. Look here, select column list from tables, table list.
Yeah.
Tables are comma separated.
Yeah.
And you can add a where condition here, that is join condition using where class.
Yeah.
Table 1's column 1 equals to table 2's column 2, right?
Yes. Yes. Yes.
Further, if you want, you can add conditions, uncondition, then finally order by, group by, all those things you can use.
Okay. All right.
Generally, the column 1 in table 1 and column 2 in table 2 would be primary key and foreign key, generally.
All right.
In our employee table, department number is a foreign key.
Yes. Yes.
In our department table, whereas department number may be a primary key.
Yes. Yes.
That's what I highlighted here. Okay.
Okay.
And column 1 and column 2 must have same data type and same size.
All right.
So this is the restriction. Okay.
Okay. Okay.
All right. This is theta style representation. Then ANSI style representation. This ANSI style representation is ANSI SQL 92 standard.
Okay.
Here we will represent join using JOIN, join keyword.
Okay.
And you can see here select column list from tables you are going to mention, right?
Yeah.
So here table 1 join table 2.
Uh-huh.
You are using JOIN join there.
Uh-huh. All right.
Then instead of where class, you are going to use on class.
Uh-huh.
That is, you are going to join table 1 and table 2 on which column? That is on table 1's column 1 equals to table 2's column 2. Okay.
Okay. And this.
For this, if you want, if you can add where class, where filters again.
Okay. And in this case, column, for example, on table 1, column 1, for example, column 1 can be primary key. Or,
Yes, absolutely.
and table 2, column 2 is foreign key.
Right, absolutely.
Okay.
And here the thing to be noticed is you are using JOIN join keyword here explicitly.
Yeah. All right.
And here you can use a where condition also here. Where conditions here will act as additional filters. you are going to use the join condition
Yeah.
in on class.
Okay.
Whereas with the theta style, you are going to use the join condition in where class, right?
Yes.
That's the difference.
Yeah. This is.
And this ANSI standard, ANSI style representation is more readable
Looks
because
easier.
you are mentioning JOIN join. So they can easily understand what join it is. That may be left join, left outer join, right outer join.
Yeah.
You are going to represent the name here.
Yeah.
Okay.
Okay.
So here, let me rewrite the same query using ANSI style. So I write here equi-join. So equi-join is theta style. And I am going to copy this, and I am going to write ANSI style. Yes. Look here, select star from EMP. We will not be putting any comma separated tables. Instead, we are going to mention join, and this condition you are going to mention on, that is join on what? This condition. Okay. Now I am going to execute this. Observe carefully. Yes, it gives the data again 14 rows.
Yes.
Right?
Right.
For now, I am not highlighting what data it is returning. Soon I will going to explain what data it is going to give.
Okay.
I just highlighted on syntax how to write both ANSI and theta style.
Okay.
Now there is another way of representing the join using class. Yes, on class we have seen, right?
Yes. Right.
Likewise we have ANSI style using join using using. Yes, let me write. Yes. So the same ANSI style, I just highlighted using. Look here, we are writing the same, that is select star from table 1, join table 2. And instead of on class, we will be using using class.
Okay.
Using what column you are going to join? What column? Let me know what column it is.
Department number.
Right, department number. Yes, look there. Using department number, and I am executing this, and it is giving 14 rows.
Yeah.
Right.
So the result is almost the same.
Same. Result is same. In all the three styles, the result is same.
Yeah.
So here you are going to represent it in ANSI style. With on class you are going to put the condition over there. On what column you are going to use that. Here, what column is known well. So I am just mentioning the column in the braces, department number. Okay. And here, this column department number with using class, I have mentioned in parenthesis.
Okay.
These parentheses are mandatory. Whereas with ANSI style on class also, you can represent a parenthesis here. If you want, you can put that. Just for readability purpose.
Yeah.
I am executing the same query after adding parenthesis. Of course, it gives the same data. There is nothing change in the data.
Yeah.
So here, the parenthesis here, I mean the parenthesis with this style, on class. The parentheses are optional. If you want, you can use, or if you skip, you can skip.
Okay.
Whereas the parenthesis braces with a using clause are mandatory. That's the difference between this type and this type. That is on clause and using clause.
Okay.
All right.
Yes, yes, it's clear.
Yes, that's fine. So that is the basic knowledge about the joins and syntaxes. Now let us highlight what type of data it is going to give by looking into this Venn diagram. By looking at this Venn diagram, you can easily sort out what type of data it is giving. It becomes very easy. Observe here. Let me highlight that. Yes. Observe this Venn diagram.
Okay.
Table, I mean, say set A and set B, circle A and circle B.
Okay.
Circle A and circle B can be considered as table A and table B.
Yeah.
For example, employee table and department table you can assume. Yes, you can see how we are representing the select operation, that is join operation. Observe the syntax here. Select column list from table A. You can see here they have used inner join over there. Just name of the join.
Okay.
Inner join or equi-join or natural join means the same I told you.
Yeah.
So on what? Table A's primary key
Yeah.
column equals to table B's primary key, right?
Yeah.
So what type of data it is going to give as a result is the common data present in both employee and department.
Yeah, like department number.
Right, department number. If you want, you can put in the department table. If you look, there are department numbers like 10, 20, 30, 40.
Yes.
Whereas with employee table, there is no 40 department with employee table.
Yeah.
Only 10, 20, 30 are seen.
Yeah.
And when you fire the join operation on this, you can see in the result, let me change it to normal. Okay. Yes, look here. 14 rows are written.
Yes.
And the department numbers, if you look, it is just 10, 20, 30. There is no 40.
Yes.
Because 40 is present in only department table, not in the employee table.
Yes.
So we are not seeing this in the result of the join, right?
Right.
That's what we are highlighting the selected portion, that is intersection of A and B.
Okay.
Good.
Yes, clear.
Now here, look here, the left join here. Left join, I am highlighting. Things become very easy to you. Look here. If you observe these Venn diagrams, you can easily understand what type of data it is going to give. Look here. Select the column list from table A and you are going to mention LEFT, left join. Table B, okay?
Okay.
For table A and table B, if you want, you can use alias names also.
All right.
On what? Same. A dot key equals to B dot key. That is EMP dot department number equals to department dot department number. When you use left join, observe carefully to this left join, LEFT left join, what is the table present to the left join? Table A.
Yes.
From table A, you get all the data.
Yeah.
All the data. That is both common to A and B tables, that is intersection part, and also data that is present only in the table A.
Yeah.
Right?
Right.
Same way you can look at the right join.
Yeah, all the data from the table B.
Right. All the data from table B. All the data in the sense both matching department numbers and non-matching department numbers.
Yes.
So you get 40 also, right?
Right, right.
Absolutely.
Yes, yes.
Yes. Now look here. This is a left join again, where you are deliberately mentioning the department numbers, the department key is null. When you mention this null, only table A's no uncommon data is seen, right?
Okay, because it's left join only will take the data from A table.
Yes, yes. Department, I mean to say B tables, the key is null.
Yeah.
Deliberately we are mentioning.
Yes.
So you get only A portion data that is uncommon, right?
Right, right.
Likewise, the same right join with A dot key is null. If you give only B type B data, you get only B data.
Okay.
That is not common, right?
Right, right.
Now here you can see there is full outer join here, full FULL, full outer join, OUTERJOIN, full outer join. Full outer join is nothing but the union of left join
And right.
and right join. That's it.
Yeah. Okay.
Yes, you can, right?
Yes.
And here if you want, you can make those keys as null. I mean to say if there is null, you can highlight only this portion of data.
Okay. Yeah.
Full outer join with A dot key is null or B dot key is null, right?
Right. Right.
That's it, simple.
Yeah, yeah, it's clear.
So if you have this picture in your mind, writing join becomes very simple to you.
Yeah, yeah. It will, I hope. Yes, all right.
Definitely, definitely. If you practice some samples, you will come to know what they are actually.
Yes, I will, of course. I will practice.
Yes, very good. For now, I am winding up the session. We will perform some samples on joins tomorrow.
Okay, okay. Tomorrow I have no school, so for me it's fine to have session 1 hour and a half if you are okay with that.
No problem. So at 3:30 we will begin?
3:30? Okay. Okay.
3:30 to 4:30.
Alright, alright.
No, all right then. No issues. Tomorrow we will be looking into joins with samples and further we will be exploring subqueries.
Subqueries. Okay.
Yes, this is additional topic after the joins.
Okay, okay. Okay then.
So subqueries and joins are very important.
Alright.
I am going to email this document.
Thank you.
All right. Yes, anything else? Something you were saying?
No, everything is fine.
All right then. I am going to send you this document via mail. You just refer to once you get time.
Okay, okay. Thank you. Then goodbye and sleep well. Bye.
Okay. Bye.
Bye.